In this problem, we'll factor a polynomial. We'll factor the polynomial 6t cubed plus 9t squared minus 15t. Let's first see if we have a common factor. We do. The common factor here is 3t. So we'll factor 3t out, and I get 3t times 2t squared plus 3t minus 5. Now I see if I can factor 2t squared plus 3t minus 5. If it does, it's not a perfect square trinomial. If it does factor, it will factor into two binomial factors that look like this, 2t and t, and this will be plus or minus something, and this will be plus or minus something. Now, the numbers that go in here are -1 and 5, or 1 and -5. And they can go in either order because it'll make a difference if it's 1, 5, and 5, 1, because 1 will be multiplied by 2 and 1 multiplied just by 1 for that middle term. So I can think of, on the side, just looking at these two parts here, 2t and t, and I want 2t squared plus 3t minus 5. My options would be -1 plus 5, or +1 minus 5, or -5 plus 1, or +5 minus 1. So I have 4 different options. Now, I'm going to check this first one. If on this first one I don't get a +3 or a -3, I don't need to check the next one, because changing the signs will only change the sign of the middle term. So let me check this one here. When I multiply, I get 2t squared plus 10t minus t minus 5. My middle term is 9t. If I change the signs, I'll get a middle term of -9t. Neither one is what I want. So I'll go to my next part here, and I'll check 2t minus 5, t plus 1. When I multiply this, I get 2t squared plus 2t minus 5t minus 5. When I add these together, 2t minus 5t is -3t. I want a +3t for middle term. So if I change the signs like I have here, I should get +3t. Let's check. 2t plus 5 times t minus 1 equals 2t squared minus 2t plus 5t minus 5, which is 2t squared plus, combining these middle terms, 3t minus 5, which is what I'm trying to get. So my factorization of this trinomial is 2t plus 5, t minus 1. 2t plus 5, t minus 1. I'd want to check by multiplying this out and seeing if I get my original polynomial. Since that would be true if I checked, and neither binomial can be factored further, I have factored completely.